Lesson 3.1 is solving one-step equations. To solve one-step equations, we need to use inverse operations. Inverse operations are two operations that undo each other. Examples of inverse operations are addition and subtraction, and multiplication and division. When we are solving an equation, we are trying to find out what the value of the variable is. So the first thing we must always do is identify the variable. In the first problem, the variable is x. So we must isolate x and find out what x equals. In this case, we are adding 9 to the x. So to undo that, we have to subtract 9 to both sides. On the left side, 9 minus 9 is 0, so all we're left with is x. On the right side, we have 12 minus 9, which is 3, so x equals 3. Now we must check to see if our answer is correct. So to check to see if 3 is a solution of x, we take 3 and substitute it in for x into the original problem. So we have 3 plus 9 equals 12, 3 plus 9 is 12, and 12 equals 12. So 3 is a solution. For the next equation, we have z minus 5 equals 7. First thing we must do is identify z, and now we're trying to isolate z. So since we are subtracting 5, we must add 5 to both sides. When we add 5 to the left, negative 5, positive 5 cancel each other out. We're left with z equals, and 7 plus 5 is 12. Now we must check. So we take our answer of 12 and we plug that back into the original problem for z. So 12 minus 5 equals 7. 12 minus 5 is 7, and 7 equals 7. So 12 is a solution for z. For the next part here, solving equations. Again, the first thing we have to do is locate our variable. Our variable in this case is x. So we have 3 times x. Now, to undo multiplication, we must divide, since multiplication and division are inverse operations. 3 divided by 3 is 1, so all we're left with is 1x, which can be written as x. On the right side, we have 15 divided by 3 is 5, and x equals 5. Now to check that, we take 5, substitute that back into the original equation. 3 times 5 equals 15. 3 times 5 is 15. 15 equals 15. So 5 is a solution for x. For the next one here, we must locate our variable, which is w. And now we have w divided by 7. And the inverse operation of division is multiplication. So we must multiply both sides by 7. On the left side, the 7's cancel each other out. We're left with w. On the right side, 3 times 7 is 21. Now we must check our answer. So we take 21, substitute it into the original equation for w, and we have 21 divided by 7 equals 3. 21 divided by 7 is 3, so 3 equals 3. 21 is a solution for w. For the next part here, we're going to solve equations using reciprocals. We have 3/5 x equals negative 9. So the variable we're trying to isolate is x. Now because we have a fraction in front of that, we learned in chapter 2 that when we multiply a number by its reciprocal, we're left with 1. So we're going to take 3/5 and multiply that by its reciprocal, which is 5 over 3, and we will do that to both sides. On the left-hand side, we take 5/3 times 3/5. It equals 1, so all we're left with is x. On the right-hand side, we have negative 9 times 5/3. Now we're multiplying fractions together. We write negative 1 as negative 9 as negative 9 over 1. And multiply fractions, multiply across the top. Negative 9 times 5 is 45. 1 times 3 is 3, and because it's negative 9, it's still negative. 45 divided by 3 is 15, so x equals negative 15. For the next equation, we have 5, 6 times w equals 10. So again, we're going to multiply both sides of the reciprocal of 5, 6, which is 6 over 5. On the left-hand side, 6 fifths times 5, 6 equals 1, so we're left with w. On the right-hand side, we have 10 times 6 over 5. 10 times 6 is 60, 1 times 5 is 5, and 60 divided by 5 is 12. So w equals 12.